This video covers section 9.1, square roots. Objective 1, evaluate square roots of perfect squares. So now that we know what it means to square a number, we can undo this and ask what number squared gives a certain number. This process is called finding a square root. We can undo the square of a number by finding its square root. We look for a square root of 25 by asking, what number would you square to get 25? One number that you can square to get 25 is 5, and the other number is -5. So we say that the square roots of 25 are 5 and -5. You might be saying to yourself, I thought the square root of 25 is 5. Well, we're saying it a little bit differently. We're saying the square roots of 25 are the numbers that you can square and get 25. So there's 2 square roots to any number. However, when we use this symbol, we're talking about the positive one. So if A is a non-negative real number, the non-negative, meaning the positive or 0, real number B, such that B squared equals A, is the principal square root of A and is denoted by B equals square root of A. So when we use this square root symbol, we'll only ask for the positive one. So then the positive square root of 25 is 5, and the negative square root is written as the opposite of this square root symbol. So every positive real number has 2 square roots, one positive and one negative. The square root of 0 is 0. We use that symbol, and it's called a radical sign. We use this to denote the non-negative square root of a real number. This non-negative square root is called the principal square root. We rarely use that phrase. We always just say the square root of 25 is 5. The number underneath the radical is called the radicand. The radicand is 25. And the properties of square roots. When you take the square root of something non-negative and you square root it, you get what you started with. And we also know that if you take the square root of something squared, that's the square root of 4, and you get 2. So the square roots and the squares undo each other. All right, example 1, evaluate each square root. Square root of 81 is the number that you square to get what's inside. 9 times 9 is 81. The square root of 576, this is kind of a big number. And so I know it's got to be between 20 and 30 because 576 is between 400 and 900. Now I know it can't be 21 or 22 or 23 because when you multiply those numbers out, 3 times 3 would be 9. It would have to end in a 9. So it's got to be either 24, 25, or 26. So I'm going to try 24. And there it is, 576. So this equals 24 because 24 squared is 576. When you take the square root of a fraction, you can just take the square root of the numerator and the square root of the denominator, and that gives us 7 over 11. Letter D, the square undoes the square root, and you're left with what's inside. Letter E, we know that 0.09 is 9 over 100. And so if we were to take the square root of 9 over 100, square root of 9 is 3, and the square root of 100 is 10, which is 0.3. So the square root of 0.09 is equal to 0.3, because 0.3 times 0.3 when you multiply decimals, you multiply the numbers. 3 times 3 is 9, and you put the 2 decimal spaces back into the problem. 0.3. So this leads me to your practice problems. I encourage you to press pause in your video and work these out. And come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. Square root of 144 is 12, because 12 squared is 144. The square root of 961, that's kind of a big number, but it should be pretty easy to find because 30 squared is 900. So it's got to be a little bit bigger than 30. 31's a good guess because 1 times 1 is 1. This is going to end in a 1. 32 would not be a good guess because that would end in a 4. 2 times 2 would be 4. 33 would end in a 9 because 3 times 3 is 9. 34 would be 16. 35 would be a 5. 36, 6 times 6 would be 36. So 31 seems like a good choice. 1 times 1 is 1. 1 times 3 is 3. 0. 3 times 1 is 3. 3 times 3 is 9. And we get 961. Square root of 169 over 144. The square root of 169 is 13, and the square root of 144 is 12. The square of square root 13, the square root and the square undoes itself, and we just get 13. And square root of 0.25, 5 times 5 is 25. So that means 0.5 times 0.5 is 0.25. Example 2, 5 square root 16. That stands for 5 times whatever the square root of 16 is, and that's 4, so that gives us 20. Square root of 36 is 6, and the square root of 64 is 8. 6 plus 8 is 14. Square root of 36 plus 64. Underneath the square root, we must add first. 36 plus 64 is 100, and the square root of 100 is 10. So we point out that it's not going to be true in general that the square root of the sum is the sum of the square roots. We can't split up a square root over the sum because we saw that these two answers were not equal to each other. And the last one, letter D, we use the order of operations agreement underneath the square root to simplify that. 25 minus 4 times 3 times negative 2. So we would multiply 4 times 3 is 12 times negative 2. 4 times 3 is 12 times negative 2 is negative 24. And then those two negatives, 25 plus 24, is the square root of 49. And that gives us 7. And this leads us to your practice problem. I encourage you to press pause on your video and work out practice 2 and practice 3, and come back when you're ready to see the solution. Now that you've had a chance to work this out, I'll work this out with you. Letter A, negative 6 times the square root of 81. Square root of 81 is 9, and so we get negative 54. Square root of 25 plus the square root of 144, that's 5 plus 12, which is 17. If we take the square root of the sum of the two, 144 plus 25 is 169. And that gives us 13. Square root of 64 minus 4 times 7 times 1, that's 64 minus 28. And so that gives us the square root of 36, which is 6. And practice 3, I hope you remember that there were 2 square roots of a number. When we find the square roots of 100, we're asking for the numbers that you can square and get 100. So you can square 10 and you can square negative 10 to get 100. So the square roots of 100 are plus or minus 10. The principal square root of 100 is 10, but the square roots of 100 are plus or minus 10. And this concludes the video for section 9.1, Square Roots. Objective 1, evaluate square roots of perfect squares.